Okay guys, welcome back. We are gonna hop into the next section of problems here. First, we're gonna start with number 21. This is in the solving linear equations portion of the packet. So number 21 and 24 are the ones we're gonna do. And both of them are solving linear equations, which you guys are pretty good at in general. But the reason that these are just a little bit more difficult is because they have fractions, and they have a lot of fractions all throughout this entire page.
That's so exciting.
So it's a good review for fractions, or if you just are trying to get it done quickly and you really hate fractions, you can also do this whole page and this whole section in decimals. So I am going to do it in fractions just to have a review on fractions. Bear with me while I write it on this whiteboard. So first you want to start with your distribution. And something to remember about fractions is that when you are multiplying fractions, you just multiply straight across for the numerator and the denominator. So 2 times 1 is going to be 2. 3 times 4 is 12. And then you're going to keep that x that was next to your 1/4. You're going to do the same thing with 2/3 times this -2. The -2 is a whole number, so a way to make that easier is to turn it into a fraction by putting it over 1 if you struggle with fractions. So 2 times -2, that would be -4. Over 3 times 1, that would be 3. Hopefully I'm doing all this math correct. Then you're going to do the same thing on the other side. So 1/5 times 4/3 is 4, right? 1 times 4 is 4. 5 times 3 is 15. Then you're going to keep that x. Do the same thing times -1 over 1. So -1 times 1 is -1. 5 times 1 is 5. So this should be the second step. And then from here, what you're going to have to do is a lot of addition and subtraction of fractions, which is actually a little bit harder.
Wait a minute, hold on.
So what I'm going to do first is I'm going to combine the constants. So that would be this 4/3 and this 1/5. I'm going to add the 4/3 to the other side, and we will see how that turns out. So in order to add or subtract fractions, what you need to do is get it so that both of them have the same denominator. We have a 5 and a 3, and the easiest way to make them both have the same denominator is to multiply each of them by each other's denominators. So let me explain what that means. So -1/5, if I multiply it by 3 over 3, I can get -3 over 15. And if I do the same thing with this fraction, the 4/3, if I multiply that by 5 over 5, I can get that to be 15. So 4/3, I can multiply by 5 over 5, and I can make that 20 over 15. And now these have the same denominator, 15 and 15. Another thing you might be wondering is, why do I need to multiply the top, the numerator, by 3 if I'm multiplying the denominator by 3? Well, 3 divided by 3 is 1. And if I multiply something by 1, it just stays the same, right? -1/5 times 1 is -1/5, which is equivalent to -3 over 15. So I'm not actually changing the value in any way. It's the same value. I'm just changing how it presents so that I can add and subtract it easier. From here, all I do is add or subtract the numerator. So over here I had -1 plus 4, but they had different denominators. Now I have -3 plus 20. So -3 plus 20 is basically 20 minus 3, which is 17. So 17 over 15. And if you wanted to do that with a decimal, what you would get is, if you divided -1, I don't know if you guys can see this. If you do -1 divided by 5, that would be -0.2. And then 4/3, 4 divided by 3. And then if you added those, so this value plus this value, you would get another decimal. And if you click Math Fraction, you get 17/15, which is what we got using fractions. So now what I'm going to do is erase. I have 2/12 x and 4/15 x, and I'm going to subtract one of them on both sides to get them on the same side. So I am going to subtract the 4/15 x so that I still have something over here, whereas if I subtracted the 2/12 x, I would only have a 0 over here. So again, I'm going to do the same thing where I need to get the denominators to be the same. Okay, so what I'm going to do is I'm going to find the greatest common factor between 12 and 15. And I can actually change this to 1/6 to make that even smaller. So 1/6 x minus 4/15 x. And I can find the greatest common factor to see what I need to multiply each of them by. So 6 and 15. Start with 6. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. 15 times 1 is 15. And 15 times 2 is 30. So the greatest common factor is 30. So what I'm going to do is multiply the 1/6 by 5/5 and the -4/15 by 2/2 to get them both to be 30. So 2/2, 4/15, oops, sorry, I meant 5/5.
Sorry to this man.
So 5/5, 2/2, and this is going to be 5/30, and this one is going to be -8/30. Okay, so now they're the same. 5/30 minus 8/30. 5 minus 8 is -3, so it's going to be -3/30. And we can actually simplify that even further. I'm just going to erase this whole thing so we know it's -3/30. We can simplify that to -1/10. So it was -3/30. We're going to turn that into -1/10, just the most simplified version. And then if we wanted to check our work, we can just quick check it on the calculator. So 2 divided by 12. And then 4 divided by 15. We can do this minus this. And that would be that. And the fraction is -1/10, which is what we got. So -1/10 x on this side equals, we can cross this out, 4/15 x minus 4/15 x is 0. And then we're going to equal that to 17/15. Now we're almost done. Now we just have to isolate x by getting rid of the -1/10. And we can do that by either dividing by -1/10, or we can multiply by the inverse or reciprocal. So we are going to multiply by the reciprocal. So that would be -10/1. And -10/1, you need to do it on both sides. So -10 times -1/1/10 cancels out. So these are going to cancel out. -17 times -10, sorry, +17 times -10, -170/15. So that would be what x equals. And I'm just going to check to see if that has a simplified fraction. So -170 divided by 15. Math fraction, -34/3. So let's see if that is an answer. Going back to 21, and the answers are in decimals. So I'm going to divide negative 34 divided by 3, and it's negative 11.3. So that would be answer choice 4. So number 21, the answer choice is 4, negative 11.3. And again, obviously it would have been much, much faster just to do this in decimals, but I think fractions are always a good skill to have, so I try to do fractions as often as possible. Okay, 24 is the next one, so hopefully here, maybe you can see 24 before I write it down. So we're just looking for the answer. Again, we're looking for what does x equal, and it sort of has some fractions, but definitely not as much as number 21, so hopefully it will be quicker. So you can actually solve this by cross multiplication, and if you forgot what that was, basically if you have a fraction equal to another fraction, you can just multiply the numerator and denominator on both sides, and then you would simplify from there. So 4 times 15 is 60, so that'll be our one side, and then 3 times x plus 10. So we're going to need to write that in a set of parentheses before we distribute. So 60 equals 3x plus 30, right? 3 times x is 3x, 3 times 10 is 30. Then we're going to subtract 30 from both sides. You guys are pretty good at this from here. 60 minus 30 is 30. That equals 3x. And then you divide by 3 on both sides. So x equals 10. And that is answer 3. And we can also check to see if that answer, we can check our answer with the original problem by substituting it back in. So if we substitute it back in, we can put 4/3 equals 10 plus 10 over 15. So our answer was 10, so I'm substituting 10 for my x. So 10 plus 10 is 20. So I'm saying 4/3 equals 20 over 15. And I can check that those fractions are the same either by simplifying this, or if you have trouble with that, you can just put it into the calculator. So 4 divided by 3 equals 1 1/3. 20 over 15 should also equal 1 1/3, which it does. So you know that number 10 is your answer. So for 24, the answer is 3. That was a lot shorter. So hopefully that helps you with some of the solving linear equations problems. That's going to be all the problems I do in this video. And tune in for another video soon. Thanks.